So, complete the square. I actually want to do this teach us in a way that is going to seem a wee bit silly, but that's okay. I'm actually literally going to complete the square, as in the shape square. Completing the square is used in algebra to find, particularly with quadratic expressions, is the thing called a turning point, which when we do quadratic graphs next semester, you'll learn all about turning points and things like that. But it's also a way of factorizing. So we'll show how we can go about factorizing this particular friend. So, I'm going to suggest that each one of these, this x squared and this 4x, are the dimensions of either a rectangle or a square. So for instance, x squared would be a square. That is x long and x wide. After all, square has to have the same sides. So a little x and a little x there. The 4x here would actually be a rectangle. I might put this in a... It's one side is x long, the other side is some distance 4. There we go. I've just turned those little duvers there into shapes. Okay, so I've just turned them into shapes. X squared is x long and x wide. 4x is x wide and 4 long. What I need to do is I need to put the two shapes together in order to make a bigger square. Mr. Schwab at the back.
By doing them, you'd make the top length 4x. That'd be right.
Yeah, so if I was to pop them together, if I was just to put them side by side, I don't get a square, unfortunately, because if I do this and I just put the other one next door to it, I get 4, I get an x, I get an x, and I get an x, like that. Unfortunately, I've just made a very big rectangle. So what I'm going to need to do in order to complete the square is I'm going to do some trimming. And what I'm going to do is I'm going to trim that rectangle in order to be able to make a square. So what I'm going to do is I'm going to cut it in half. So I'm going to cut this in half. And what I'm going to do so if I was to cut that rectangle in half, what would be the length now? That was originally 4, what would it be now? 2. So that's x long, that's now 2 long. So it's still a rectangle, but that's all right. We'll take the other half. We'll plop that over here, and we get x long, and that's 2 long. So close! Damn it! I've got one small section left, which is this little square duva here. What would be the dimensions of this?
2 by 2.
It'd be 2 by 2, wouldn't it? So, in order to complete the square, I would need to have a little square that was 2 by 2 long. And how
So this is the weird diagrams that are in the textbook.
That-
It's just the squares all over the page.
That's exactly right, yeah. So, what I've been able to do was to take this little expression here, and I'm just rearranging it in order to try to make a square, a pretty square out of it. So, basically what I'm trying to say is this expression, if it just had a little plus 4 at the end, I'd make a very beautiful square. So, that's exactly what we're going to do algebraically. So, I'll show you what I mean. In order to make a very beautiful square, I would need to add, what's 2 times 2? 4. But hang on just a moment. That's nonsense. I can't just add a random 4 because I felt like it. So what I'm going to do is I'm going to minus 4 as well. Because there wasn't a 4 there. This was utterly nonsense. I can't just make up numbers. So, but hang on just a moment. X squared plus 4x plus 4. Can anyone find me, if I wanted to factorize that blue section, how could I, what would go in each of the brackets? I could tell you an x goes there and an x goes there. plus 2, another plus 2. Minus 4. Because 2 times 2 is 4. 2x times 2x would be 4x. Or 2x plus 2x would be 4x. And suddenly, I've got a square. And now, I have completed the square. This time, I've got x squared plus 7x plus 1. So, okay, what I'm trying to do is I'm trying to complete the square. So this 1, unfortunately, is not going to be very helpful to us because it's not multiplied by anything. See how these were all multiplied by something? Like this would be a very lovely square, x and x. This would be a very lovely rectangle that was x long and a distance of 7. Unfortunately, 1 doesn't have a dimension. It's just plus 1, so we'll just chuck that at the end. It's a plus 1. It doesn't have, I can't make a shape out of it. It's a straight line that's 1 long. So it's not going to get involved. So what we need to do is we need to complete the square. So we need to make a big square. So once again, I'm going to do exactly what I did the last time. I'm going to cut this one in half. So one half of it, that's going to be excellent. What would be the length now? 3.5, yep, 3.5 long. Hang on just a second, Mr. Schwab. And I'm going to put the other one down here. So this was 3.5 long, and it's x distance. I might even just make this a wee bit longer so that it doesn't look exactly the same. There we go. So now to complete the square, I need to fill in the gap. How big is the gap here? 3.5 by 3.5. So, in order to complete the square, I would need to do x squared plus 7x. And what we're going to do plus... What would be... what's 3.5 as a fraction, by the way? 7 over 2. I'm just going to write it as 7 over 2 for just a moment because that way it's easier to square. So 7 over 2 squared, because 7 over 2 times 7 over 2, which is 49 over 4. Okay? And because it doesn't actually exist, I can't just add a random number. I'm going to take it away as well. Oh, I better not forget my little plus 1 over here, because that would be a bit sad if I did. And then, what I'm going to do is I'm going to now factorize this. So, two numbers that multiply together to get 7 over 2 squared, but add together to get 7. So, could anyone figure that one out? What would be two numbers that multiply together to get 3.5, add together to get 7? Oh, sorry, multiply together to get 3.5 squared, add together to get 7. 3.5. 3.5, yeah. So the little brackets, 7 over 2, minus, and so what did we say 7 over 2 squared would be equal to? 49 over 4, plus 1. And suddenly, we have completed the square. Negative 49 over 4 plus 1. How could I express plus 1 as a fraction with a denominator of 4? Yes?
So make it 4, yeah.
Make it 4 over 4. So negative 49 plus 4, what would that be? Negative...
Oh, sorry, negative 53. It's negative 45. 44.
Is it negative 45 or negative 53? Which one is it?
45.
Yes. Negative 49 plus 4, negative 45 over 4. Now, This could be entirely bullcrap. What I could have said was, nonsense, where does this complete the square? Did I just make things up? Am I inventing mathematics? Well, we can determine this by proving that what I've just said was correct. So by proving it that we are correct. We're going to go back to the well, I can start with this question actually, since I've got here. I'm going to prove that by expanding this, I should get my original answer. So here's my proof.
You have to write down the proof.
You don't have to write down the proof, but if you look at your notes later and go, but what is this nonsense, maths? It would be nice. Okay, so what I'm going to do is I'm going to expand this bracket. So this is going to be x plus 7 over 2, x plus 7 over 2, minus 45 over 4. So this, again, we're going to expand. So this becomes x squared plus 7x over 2 plus 7x over 2 plus 49 over 4 minus 45 over 4. And then x squared plus 14x over 2 plus 49 over 4 minus 49 quarters. Take away 45 of those quarters. Makes that 4 quarters left. 14x divided by 2, what would that be? 7. 4 divided by 4? And there we go. We have just achieved that this delightful amount of nonsense maths works. The next step after completing the square is you'll get questions such as factorize by completing the square. This relates to our previous example about factorizing by perfect squares. I'm going to use this example here, x squared plus 7x plus 1. This can't be factorized into two lovely brackets because no two numbers multiply to get 1 that add together to get 7. 1 plus 1 does not equal 7, and no matter what kind of bizarre voodoo maths you happen to be using. So we need to be able to try to get it into two sets of brackets. Earlier we completed the square, so we realized and we proved that this could also be written as x plus 7 over 2 squared minus 45 over 4. Well, suddenly this is awfully similar to those other questions we did earlier, such as these ones down here where I've got something squared minus another number. I could do the same over here. This can now be put in two brackets. One bracket would have, because that's squared, so both of these brackets would start with x plus 7 over 2. And then there'll be a minus, and there'll be a plus sign. And there's 45 over 4. Well, that would be the square root of 45 over 4, square root of 45 over 4, which we can simplify to just being x plus 7 over 2 minus the square root of 45 over 2, x plus 7 over 2 plus square root of 45 over 2, because the square root of 4 is equal to 2. And also you could have that that would be correct, or if you wanted to have it in surd form, it would also be 3 root 5 over 2. And the second bracket would be x plus 7 over 2 plus 3 root 5 over 2. So that's what would be the next step, being able to use completing the square to go and get something factorized.